Okay everyone, welcome to algebraic division. Okay, algebraic fractions, why do we need them? So let's start simple and look at some numbers first. So in front of me I've got 7 over 3. Now it's called a top-heavy or an improper fraction because the 7, the numerator, is bigger than the 3, which is the denominator. Now 7 divided by 3 is, let's have a think, 7 divided by 3 is 2, remainder 1. We could write it as 2 and a third, couldn't we? But I'm going to keep it as 2 remainder 1. And I'm just going to show you a few little bits over here because I want to show you a little bit about what's what. So the quotient is what you get left over. So my quotient would be my 2. All right, there's my quotient, there my 2. The remainder is obviously what you get left, so there's my remainder. The divisor is what you're dividing by, so in this case my divisor is 3. And the dividend is the thing being divided, so in this case it was 16, but in my case the dividend is 7. So sometimes the questions will say find the quotient and the remainder. So there's the quotient and there's the remainder. Okay, now on this side what I'm going to do is I'm going to now write this 2 remainder 1 in a slightly different form. So 7 is the same as, we change our colour, 2 times 3. All right, so those two can be timesed up. Remainder 1, and in fact we would have to add the remainder on to get back to 7. So 7 over 3 is 2 remainder 1, or 7 is 2 times 3 plus 1. Okay, now algebraic fractions work in exactly the same way. So in front of me, what I've got now is x cubed plus x squared plus 2x minus 1. That's my dividend, divided by x squared minus 1. That's my divisor. And I'm actually just going to tell you the answer. You're not going to like this, all right? You're not going to know where it comes from, but I'm just going to tell you that the quotient, when we divide them, don't panic, in a minute I'm going to show you how I get it. The quotient is x plus 1, and the remainder is actually 3x. It's a bit strange, isn't it? Now, this is here an improper fraction, and I'm going to tell you how we know. First of all, if we look at the top, the numerator, it's a polynomial. A polynomial is just a collection of x's, and we would say that the order, we call it the order is 3 because the highest x power has a power of 3. So the order is 3. And if I look at the order of the denominator, the highest x power is squared. So the order is 2. And therefore, 3 is bigger than 2. It's an improper fraction. In fact, it's an improper fraction if the numerator is the same or bigger than the denominator. So if the order is the same or bigger, all right, it's an improper fraction. So in fact, strangely enough, this would be an improper fraction because the orders are 1, therefore they're the same. And of course, if it was 2 or 3 or 4 or 5, it would still be an improper fraction. So in algebraic terms, that's how you know if you've got an improper fraction. Okay, right, let's have a look and see if we can write this in a slightly different way over here. So what we did was we said here on the top one, we did the 3 times 2. So we did the quotient times the divisor. So the quotient is this, the divisor is this, and if we times it back up, we will get x plus 1 times x squared minus 1. I'm slightly running out of space there, so I'll put a times in so that you can see that. And then what we did up here, so that's that bit done, and then what we did up here was we added on the remainder. So here comes my remainder being added on, and here's my remainder being added on, so plus x plus 1. Now, you haven't got a clue at the moment how I've got any of that, but I'm just showing you that the algebraic fractions will work in exactly the same way as the numbers. Okay, now, how did I know in that last question that my quotient was x plus 1 and my remainder was 3x? Well, I did it using a process called algebraic division. And before we do algebraic division, what we're going to do is we're just going to remind ourselves what numerical division looks like. Okay, so 2, 3, 4, 6 divided by 11. You did long division when you were little. Okay, 2, 3, 4, 6 divided by 11. How many 11s are there in 2? None. How many 11s are there in 23? there are 2 of them. And notice that once I've decided there are 2, I'm actually saying to myself, I'm going to multiply back down. So 2 times 11 is 22, and obviously the remainder is 1. But in order to find the remainder, I'm going to say 2 times 11 is 22, and I'm going to use a subtraction. So I meant to put him in red. And we're going to subtract to find that remainder of 1. Okay, now some people would put the 1 up here to make 14. They'd say how many 11s in 14. But what I'm going to do is I'm going to move the 4 down. All right, so I'm not actually going to put that 1 up there. Let's rub him out. I'm just going to leave it like that. Okay, so how many 11s are there in 14? There is 1. And then I'm going to multiply back down. And then 1 times 11 is 11. And I'm going to subtract to find the remainder. So the remainder is 3. And some people would put the 3 up there, but I'm not going to put the 3 up there. I'm going to move the 6 down. So how many 11s are there in 36? There are 3. And then I'm going to say 3 times 11 is 33. And I'm going to subtract to find the remainder. So 36 take away 3 is 3. And therefore, 2, 3, 4, 6 divided by 11 is giving us a quotient of 213 and a remainder of 3. Okay, so let's just make him small. See if we can squeeze him up. You're going to have to keep a little bit of an eye on him. And we're going to go into my algebra. So x cubed plus x squared plus 2x minus 1. So we're going to start off by writing x cubed. Some people call this the bus stop method, don't they? Plus 2x minus 1 all over x squared minus 1. Okay, in the number one, I said how many 11s were there in 23. When I'm doing the algebraic one, what I do is I'm only interested in the first part of the polynomial. In fact, I'm just going to move my question out of the way. There's my question. Right, so I just say to myself, how many x squareds are there in x cubed? Now, how many x squareds in x cubed is a bit tricky, so it's much easier to say x squared times something gives me x cubed. Okay, x squared times something. Well, x squared times x must give me x cubed. Now, let's go back to the number one. When I did the number one, what I had in here was the minute that I decided that the 2 was on the top, so the minute I decided that he was on the top, I multiplied him back down. All right, so what I'm going to do is I'm going to do the same thing here. So I call this, have you guys seen this person before? All right, you're probably too young, but there's a really fab film called Edward Scissorhands. That's who he is. That's Johnny Depp. Can you believe it? So Ed Scissorhands, and notice he's got big fingers. And the reason I'm going to say, instead of saying multiply back down, I'm going to say Edward Scissorhands back down, because what I want you guys to do is you multiply. We still multiply, but we multiply both parts. So I want you to think of those both parts as being Edward Scissorhands' long fingers. All right, so we Edward Scissorhands back down. So x times x squared, so x times x squared will give us x cubed. And notice that I line it up underneath the x cubeds. And x times minus 1 will give us minus x. Now notice I don't put it here, all right? It's not going in there. It's got to be lined up. So that lines up underneath the x's. So it lines up here, minus x. Okay, so the next thing I did when I did my number one, let's bring my number one back down, is I did this little part here on the subtraction. So I decided that 23 take away 22 gave me 1 here in the subtraction. So what I'm going to do now, let's put him back again. What I'm going to do now is I'm going to subtract in here these two parts. Okay, so let's do some subtraction. X cubed take away x cubed will give me no x cubed. And in fact, what you'll find is that I won't bother writing that. Okay, I've just written that for you for the beginning. Okay, x squared take away nothing. There's nothing in there. Gives me x squared. And 2x take away x. Okay, 2x minus x. Be really careful. The minus will go to a plus, and therefore I'll be left with 3x. So that is my remainder. Okay, what did I do in the numbers? Then in the numbers, once I had my remainder, I brought it down, didn't I? I did this little technique of bringing my remainder down. So I'm going to bring my remainder down. And then whatever my remainder was, so say I had 36, I then started the whole process again. So here we go, starting the whole process again. Underline the first one and say to ourselves, how many x squareds are there in x squared? Or x squared times something gives me x squared. Okay, well x squared times 1 gives me x squared, and the minute that it goes on the top, we're going to Edward Scissorhands him back down. So 1 times x squared is x squared in here, and Edward Scissorhands 1 times minus 1 is minus 1, and we're going to line it up underneath, all right? So in here, now we're going to do my subtraction. X squared take away x squared is nothing, so I'm going to kind of ignore him, not bother writing him in. 3x take away nothing is 3x, and minus 1 minus minus 1, minus 1 minus minus 1. I do suggest you write this out at the side because it's these little bits that you're going to go wrong on. Minus 1 minus 1 makes a plus, and therefore there is nothing left over. Now at this point, I know I've actually stopped because the power here is a 1, and that is smaller than the power here, which is a 2. We can't say how many x squareds are there in 3x. It doesn't really make sense. So I've finished. Now what I'm going to do is I'm just going to move this up so that we can write our answer. It's kind of squishing. My x is staying the same, but we can just about see that. And therefore, what we can do is let's just write this out as a complete answer. So x cubed plus x squared plus 2x minus 1 divided by x squared minus 1 gives us a quotient of x plus 1 and a remainder here of 3x. And of course, if I wanted to write it in the other form, x cubed plus x squared plus 2x minus 1 is the same as this times this. So x squared minus 1 times x plus 1, and the remainder would be plussed on. Okay, that's it. Let's try another one. Okay, we're going to have a look at what happens with this question when we do this division, and we want to show it can be written like this. Okay, let's begin. So, what have I got? X cubed plus 3x squared plus x plus 2, and I am dividing it by x plus 1. Okay, let's begin. So we're going to take the first part and we're going to say how many x's are there in x cubed, or what do I have to times x by to give me x cubed? So I reckon what I have to times it by is x squared. Okay, let's pop that in. So x squared. Minute he's on the top, my good friend Mr. Edward Scissorhands comes into play. I'm going to put him up here so that we don't forget him. There he is. And we are going to multiply back down. So x squared times x gives us x cubed, and x squared times 1 gives us plus 1x squared, and making sure that they are beautifully lined up. Okay, and we're Edward Scissorhandsing because we're timesing down both bits. Right, here comes the subtraction. X cubed take away x cubed is no x cubed, and 3x squared take away x squared is 2x squared. And I tend to actually personally, to save it looking really messy, I tend to not bother writing that bit in. Okay, so then what we're going to do is we're going to pull down what's left, and I tend to pull down everything, and then we're going to start again. How many x's are there in just the first bit? 2x squared. Or what do I have to times x by to get me 2x squared? I reckon we have to times it by plus 2x. The minute he's on the top, we're going to Scissorhands him back down. So 2x times x will give me 2x squared, and 2x times 1 will give me plus 2x. And now we're going to subtract. Okay, so here comes the subtraction. 2x squared, take away 2x squared is no x squared. And we said before, didn't we? Tend to not do that because in case it gets messy. And x take away 2x is minus x. And we're going to pull down what we have left. Okay, here we go again. How many x's are there in minus x? There are minus 1 of them, or minus 1 times x gives me minus x. And the minute it's at the top, the minute he's at the top, we set Edward Scissorhands him back down. Minus 1 times x gives me minus x, and minus 1 times 1 gives me minus 1, doesn't it? Okay, so minus x minus minus x. minus x minus minus x gives me nothing. All right, so there's a nothing in there. And 2 minus minus 1, 2 subtract minus 1 gives me a plus 3. So, in fact, I tend to not bother putting the nothings in. So, that's it. Okay, so now I'm going to just move him back so that we can actually answer this question. And before we answer the question, I'm just going to go back to my 7 over 3. Now, do you guys remember that we said 7 over 3 was 2 and there was a remainder of 1? And actually, if I wanted to, I could say to myself that 7 over 3 is, now let's have a think, it's 2. And I could, if I want, write the remainder as a third, couldn't I? And would you be happy that I could also write it as 2 plus a third? So this is exactly the same. I want to write it in, or the exam question wants me to write it in this form. So ax squared plus bx plus c, well, that's the same as my 2. So that's the same as this part up here. So x squared plus 2x minus 1. And this part is just the same as this part. So the 1 is the remainder. My 1 is my remainder. So in this question, my 3 is my remainder. And the remainder is put over what I was dividing by. So I was dividing by 3, and that's why there's a 3 on the bottom. So what was I dividing by? I was dividing by x plus 1. And so sometimes you'll see them ask for it in that form. Okay, there we go, done.